All right, so as promised, here we're doing another example. So we have a piecewise defined function, but notice now there's three pieces. If x goes from -4 to 2, I need to compute this. If x is exactly 2, I compute that. And if x is bigger than 2, I compute this. Okay. So let's find f of 0, f of 2, f of 3. Just determine which one of these three conditions is met. Ask what's the domain, locate intercepts, graph it, and find the range. Okay, so again, I'm going to pause. So go ahead and try to do these 5 parts. All right, I'm going to go on. So for f of 0, we're in between -4 and 2, so I'm going to use that first branch. The different pieces are sometimes called branches. I'm going to use that first computation, where f of x is x plus 2, plug in 0, get out 1. But if I'm plugging in 2, that's exactly that middle condition. When x is exactly equal to 2, we use the middle condition of f of x equals 2. So there it is, it's 2. But if I'm plugging in x equals 3, I'm going to use the third condition, which says x squared over 3, and I get 3. Part B, what's the domain? Well, it's just the union of the domains of each respective piece. Okay, so the first piece told me what to do when x was in between -4 and 2, and then I was told what to do at 2, and then I was told what to do from 2 onward. So overall, I can go anywhere from -4 off to infinity. And remember, you never include infinity in your interval notation because it's not a number. So the domain is everything from -4 to infinity, or you could just say x is bigger than or equal to -4. All right, how about y-intercepts? That's just a matter of letting x be 0, and the only thing to be careful of is which part are you computing. If x is 0, we're in that first part where f of x is x plus 2, so we get the intercept of 2. Now, to find x-intercepts, we set y equal to 0, and we're going to do the same thing where we do it on each branch, and then ask, was I actually in that condition? So on the first bit, x has to be between -4 and 2, and we would use the function x plus 2, and that gives me x is -2, which is really in between -4 and 2, so this is a genuine intercept. Okay. For the middle branch, x has to be exactly 2. But what's f of x on that middle piece? It's exactly 2. Is 2 equal to 0? It isn't. There's no way to make that work. And on the last bit, if x is bigger than 2, we compute x squared over 3. Now, if x squared over 3 is 0, you solve that and you get x is 0. But remember, we were requiring x to be bigger than 2. So this is not actually on that branch, so it's not an intercept. So the only intercept we found was at x equals -2. Okay, the first one works. It's on the branch it's supposed to be on. The second one didn't exist, and the third one also didn't work for its condition. So the only intercept, the only x-intercept is at -2. So we have a single y-intercept and a single x-intercept. We always have a single y-intercept, but here we have a single x-intercept as well. Okay, next. Graph this function. So we just have to draw graphs of the individual pieces, being careful to only graph them where they're defined. So I'll erase this in a second, but if I was to graph the line x plus 2, it would look something like this. However, I'm only graphing it from x goes from -4 to x equals 2. So the graph is not going to include stuff off on either direction there for that particular branch. Okay, so the book is about to give us a nicer picture, so let's erase that. Okay, then I have a single point where x is 2, and then I have the parabola, but that's only defined when x is 2 or larger. So the individual pieces look like this. Okay, so there's that line. Okay, it does include when x is -4, but it doesn't include when x is 2. When x is 2, I have this single point, and then for x being bigger than 2, we graph this parabola going up. So it's a strange little graph, but it is what it is. You know, let's not shame it for being in several pieces. When you do want to find the range, however, you can look at this and say, well, what do we got? We've got a minimum here, everything up to this value, which is then sort of duplicates that, so that doesn't really affect the range. I start down here, which is still duplicating some values I've already seen, but then I'm going to go up forever. So what do I get out? I can get out -2 and anything above it. So there's our range, -2 and anything bigger. Okay, another example. In the spring of 2015, a particular project supplied electricity to Arizona for $20 plus 11.48 cents per kilowatt hour for the first 700 kilowatt hours, and a slightly higher price for all usage above that. This is pretty typical. They'll give you a certain amount of electricity at a low price, but if you are a high usage customer, they start charging you more for the more electricity they send you. So what will be the charge for 500 kilowatt hours or 1900 kilowatt hours? And if C is the monthly charge, can you actually come up with a function that expresses this relationship? C, cost, as a function of X kilowatt hours. Okay, so I'll pause for a second, try to answer what's the charge for 500 kilowatt hours, what's the charge for 1900, and then can you come up with a function that can allow you to compute anything you want? All right, moving on. So 500 is under that cutoff of 700, which means the charge is just $20 plus 11.48 cents per kilowatt hour. So I just have $20, that base fee. This is the cost per kilowatt hour times how many I used, and it works out to be $77.40. Okay, for 1900, however, we have different costs for different kilowatt hours. So for costs going from, say, 0 to 700, we're using 11.48 cents. But from 700 to 1900, we're using the higher cost of 11.60 cents. Okay. So we have a total of the $20 base fee, 700 kilowatt hours at this price, and then the next 1200 kilowatt hours at this price. Okay, the total was 1900 and the price changed at 700, which means 1200 kilowatt hours are charged at this higher price. And if you simplify this down, you get $239.56. The final part is how much, what function can we come up with that represents this overall? So if the number is between 0 and 700, okay, then all you do is do $20 plus the number of kilowatt hours times the cost. Pretty straightforward, okay? But if X is bigger than 700, let's try to figure out what this is expressing, okay? We charge $70 base cost. Assuming we had more than 700 kilowatt hours that we purchased, the first 700 are at this price. Everything after 700, and if X was the total, how much of it is after 700 is X minus 700. Everything after that is at this cost. But this only makes sense when X is bigger than 700. Okay, because if X is, say, 200, it's smaller. This term here would be negative, and it would be subtracting cost. It doesn't quite work out. X has to be bigger than 700 for this term to represent the excess usage at the higher price. Okay, and if we simplify this down, the $20, pardon me, we have 700 times this, 0.1148, 20, and when I distribute this, we're going to get a minus 700 times 0.1160. And that works out to 19.16, and then the only term involving X is this 0.1160X. So overall, we have a piecewise function. If X is between 0 and 700, it's computed according to one thing, and if it's bigger than 700, it's computed according to another. Which graphs as follows. It's very subtle when graphed like this, okay? But at 700, this does change. Specifically, what's the slope of this line? 0.1148. What's the slope of this line? 0.1160. So it's very hard to tell from this picture, but the slope changes. It actually starts going up slightly faster. Okay. The scale on the graph is such that it's very hard to tell visually. But the good news is we don't need to see it visually. We just see it from the equations that, yes, the slope changed. These are both lines, but once you hit 700 kilowatt hours, it starts increasing faster. Okay. So yeah, it's two lines that do meet at a point. If you plug in x equals 700 to either one of them, you'll get out the same thing, but the slopes change. Okay, so that finishes up section 2.4, using piecewise functions. Also some stuff about a library of functions, x, x squared, x cubed, cube root x, square root x, absolute value x.